So I'll start by talking a bit about where we see DePIN is at right now and how Streamr kind of fits into that. Then we go a bit deeper into what Streamr actually is and does, and take a look at some of the use cases. And in the end, we can have as much questions and discussion as you guys want. I'd love it if that part becomes very interactive. So that would be very cool. All right, so going into it. So how we see it is that DePIN is really cementing itself fast as one of the hottest narratives for a potential future bull run and beyond. And we think that DePIN will be one of the Web3 sectors that kind of brings in new users to the crypto space. As much of the services that are being built in DePIN are really end user products. In my opinion, in general, crypto kind of has a tendency to build infrastructure on top of infrastructure on top of infrastructure. But in this sector, there are actual applications that can reach the ordinary user, and that's very strong. And DePIN is enjoying significant support from the likes of Messari, and there's take up in mainstream crypto media. It's on the rise. So yeah, congratulations to all of you for being in the right sector. Super cool. As for Streamr, some people see us as one of the DePIN OGs, having launched in 2017. And I think today we can contribute to the space quite crucial infrastructure. And we look to support and connect with all other projects in the DePIN space, since we believe that by working together, we can help accelerate the growth of the market. So we very much have an open door and hope to work with each of you over the years to come. And Streamr even made it here into this chart. Wow, there we are. Awesome. So what is Streamr and what does it kind of have to do with anything? There's multiple ways to describe it. The top one is mine, and the bottom two are from the community. All of them are quite good. So basically, Streamr is a decentralized data broadcasting protocol. And in the DePIN context, you might think of it as kind of enabling a group chat for machines. So lots of devices can join a channel and securely transmit or receive data in real time and at massive scale. And the key thing is that it's fully peer-to-peer. So, there's no servers, no single points of failure, no trust required. You control your data traffic. And there's different messaging patterns that are possible. Kind of inherently, it implements the pub-sub messaging pattern, which is kind of many-to-many by design. But of course, you can have their one-to-one, one-to-many, many-to-one. All options are out there. And a couple of ways that people tend to compare Streamr. One is sort of technical analogy. People say that Streamr is like BitTorrent, but for real-time data streams. So if you on BitTorrent you can share files peer-to-peer. On Streamr, you share data streams peer-to-peer, and that sort of makes sense from a technical standpoint. And then one person in the community described Streamr as the chain link of DePIN, and that's more of a conceptual analogy. We're technically nothing like Chainlink. We're not an Oracle thing, but Chainlink is middleware that can connect smart contracts to off-chain resources or other chains, and similarly, Streamr is middleware that can connect devices to each other and to external audiences. So it kind of plays a similar role, even though the product itself is very, very different. Just to understand a bit better. So here's two pictures. On the left, you can see the traditional way of brokering data. everybody basically connects to a server, and then the server just pushes the data to everyone that needs it. But the problem is, in this picture, you can imagine what happens if there's like 1 million of these devices that all connect to the same point. You get scalability problems, you get kind of that server as a single point of failure, and also whoever runs that server gets a lot of power in the system, so you get trust issues and so forth. But on the right, you can see a simplified example of what happens on Streamr. So the devices and applications, they just interconnect over this peer-to-peer mesh of sorts. And now if you multiply this picture 1 million times, we just boom, 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 you can see how it doesn't create that centralized thing at all. You can kind of continue infinitely in all directions as long as you want. And everyone remains connected to a few other nodes, but even if there's 1 million nodes, nobody needs to connect to 1 million nodes, right? As opposed to the centralized version. And that's really the simple secret of how it works and how it scales and how it stays decentralized. So what we aim to do in DePIN and other Web3 projects is to have just real-time communication channels without having to sacrifice the D in DePIN. So making sure that everything's decentralized when it comes to data. Here's another picture to just give you like high-level overview. So through this global mesh of peer-to-peer connections, data can flow from any number of publishers to any number of subscribers in roughly like under 300 milliseconds globally. That's coming from our real-world measurements, which we've done for networks of up to around 100,000 nodes. So pretty big scale, but there's still like, there's billions of connected devices probably. So there you have it. And the data can be anything, can be telemetrics, messages, even binary payloads like audio or video. And the nodes themselves, they can be anything. So they could be IoT devices, they could be, base stations, they could be mobile devices, they could be even websites running in browsers and so forth. All of that is possible. Here's a realistic picture, not a marketing picture, but real picture of a peer-to-peer mesh with around 30 nodes in it. And again, the secret of Streamr Network is at the same time kind of simple and kind of hard to explain. So everyone who gets the data also helps relay it onwards to other nodes that want the data. And that way it reaches everyone eventually, regardless of how many there are. And no one needs to do more than a small fixed amount of work. And each data stream is basically like a separate mesh like this here, and consists of data publishers and data subscribers, and optionally some incentivized nodes called operator nodes that are there to boost the connectivity, stability, and security of the data stream. But that's a bit of a rabbit hole. So let's talk more about the incentive layer and all that stuff maybe in the Q&A section. So moving a bit more towards use cases. Before we go into specific ones, it may be useful to go through a couple of use case patterns or shapes, that we encounter in almost every DePIN project. Everybody needs at least one of these to happen usually, and often several at the same time. And all of them are possible to do in the Streamr protocol. So we have kind of the up pattern. There you'd have a data source that just needs to push its data somewhere to make it available to whatever subscribers or audience there are. but that device doesn't need the data from other similar devices. So you could have like IoT sensor thing or data crowdsourcing use case or something. You're just pushing it up and you don't want it to go into some centralized cloud. Then we have the across pattern where devices kind of are interested in each other's data. So they share a channel and they want to share data with each other. This could be like base stations or some protocol nodes coordinating or validating each other, or for example, cars in an area sharing traffic information with each other and so forth. So the data goes kind of more across. And then a popular one is also the broadcast pattern. It's more like one-to-many type of thing, where a single source is publishing data that needs to go to a lot of recipients, like everybody. And that could be notifications over the air, updates to devices, could be config changes, you're pushing some new config to a big fleet of devices, or it could even be a live video feed, like a security camera or whatever you have there. And we could drill down into some particular projects and partners just to give you a quick snapshot of what people are actually building. Let's look at DIMO, which is very heavily in the DePIN space and powered by Streamr. So here on the slide, we have DIMO is an extensible, scalable, open IoT software platform that allows drivers to share and monetize their vehicle data. So basically, DIMO connects car data through a hardware device that you plug into your car. Maybe you guys are familiar with this project. And the data from the devices, it goes to the Streamr Network and can be made available in real time to any stakeholders like car manufacturers, fleet operators, insurance companies, or the driver themselves and their friends or whatever. And this allows a whole ecosystem to be built on top of the data as it kind of flows seamlessly to builders that can create value-adding applications on top of that. So very cool. And then another really cool recent thing we did with IoTex and WebStream, where data from Streamr was connected to their zero-knowledge prover. So ZK stuff. This means that facts about data can be proven without revealing the data. And best of all, it can be sort of validated on-chain, right? So you could, for example, prove that a device location, for example, is in a certain area without revealing the exact coordinates, or that a car has been driven less than 50,000 kilometers without revealing the exact reading of the odometer or other information about the car, and so forth and so forth. So, that's pretty cutting edge right now, but could in the future enable, for example, on-chain insurance as a kind of DeFi pool of sorts, with insurance buyers and insurance sellers interacting trustlessly with data-driven pricing and on-chain settlement of claims. Quite exciting. Another interesting use case is metrics collection, which is something we've been looking at together with POLYGON. So the thing is, in decentralized networks, nobody has good visibility into what's happening at each individual node, right? Because they're run by different people by definition. So on Polygon POS, on Polygon Proof of Stake, they have 105 validator nodes, of which Streamr is one, by the way. And they are run by different parties. And while it's kind of easy to see whether the validators are successfully participating in the actual consensus protocol, it's kind of hard to see what's wrong what's wrong if they fail, or predict failures in advance. You kind of only see it when it fails. So each individual node operator actually can't even tell whether their node is caught up with the latest block in the chain without somehow obtaining data from other nodes. You know, if my node is going at block number 1,000,000, I don't know if it's the newest one or not. Maybe somebody else is going at block number 2,000,000 or whatever. So I might be behind. I might be in some fork of the chain. So that's why the sharing is important. And you know, the trivial solution would be to set up some centralized metrics server. A lot of chains do something like that, and then they convince each node to kind of push data there. But again, that adds centralization. It silos the data, and neither of which you can really have if you if you want to be a decentralized project. If you're a high-profile project, all aspects of centralization kind of bring something to attack, and they could bring legal concerns and all that kind of stuff. So everybody wants to be decentralized, but it's kind of hard. So by creating this data sharing possibility over a decentralized protocol, and this low-level information about the node health can be made available across the validators and to the Polygon team and to the wider community, not only for transparency, but they can also build tools and alerts and dashboards and that kind of stuff on top of that data. Maybe the last one to drill down into is Swash, a good example, again, of data crowdsourcing. And this isn't really DePIN, but it's really cool because it's very mainstream. So, it can immediately be used by the guy on the street and your grandmother and so forth. So kind of similar pattern than in DIMO, but it's fully software and sort of more approachable because of that. So like it says here, Swash is a browser extension that allows its user to take ownership of their browsing data and enables them to earn tokens in exchange for sharing this data. So basically, this browser plugin, it sends completely anonymized, completely transparent data about your activities on the web. Like literally, you can see what it's sending and check that it's not kind of spying on you or spying on you in a way that you don't know, right? So it can share, for example, what you search for on Google, what sites you visit, what you buy on Amazon, and all of that is unlinkable to your identity, who you are actually in the real world. And that anonymous data is then sold for market research or competitor analysis, that kind of purposes, and the users get most of that revenue. So, so a lot of mainstream people actually earn their first crypto with this. These guys, they have 300,000 downloads and 50,000 active users last that I checked. So it has potential to reach a lot of people and act as a sort of easy on-ramp into this type of pattern where you can earn with your activity. And in Swash, again, the data flows through the Streamr protocol. And the point of this slide, I guess, is to point out the potential in, data monetization and data crowdsourcing type of use case, which are both popular and recurring use cases in the Streamr ecosystem. Like I mentioned, DIMO is the same, right? The compulsory logo slide, a couple of other projects in the DePIN space that we currently work with include Mapmetrics, Arcreen, Peak, Hotspotty, IoTex, I mentioned already, Noodle, Flux, Future 3 campus, and so forth and so forth. And of course, there's a bunch of partners and builders also outside, but these might be familiar names to you guys. A little bit about how to try it out and how to use it. So this is more for the developers among you. It's pretty easy to try out Streamr and integrate it into your projects. There's basically 2 tracks. So our implementation natively targets like JS-based environments, meaning Node.js and browsers. So you can just kind of import the SDK from NPM and embed a Streamr node right into your app or web app or whatever it is, web page, whatever you're building. But in case you're writing in, Rust, Go, Python, or whatever else, then your integration path is to run a Streamr node as a separate process, kind of separate from your application, and interface with that node from your application over a bunch of interface protocols available, which include HTTP, WebSocket, and MQTT. And if you have an idea, we also have a grants program for devs. There's basically 2 tiers there. The more lightweight innovation grants, they go up to 5K. And then the more substantial applications can get up to 50K from the grant fund. That concludes the intro presentation part, and I'll hand over back to Rob to host the Q&A and discussion part. But I'll just leave you with a final teaser that the Streamr 1.0 mainnet, which is the biggest Streamr milestone to date, and kind of marks the feature completeness of the protocol, is launching in February. So we're just a couple of weeks away. So keep an eye on this space. Thanks.